So let's quickly look at associations and correlations. So this is essentially, when we have two different categorical variables, one would be interested in finding out whether they are positively associated or negatively associated, or whether there's an association that exists or does not exist, and that's where we use a test called chi-square test. Essentially, what chi-square metric does is it basically punishes the difference between observed values and expected values by squaring the difference, and then that's summed over rows and columns, which is number of observations and number of features. So that's basically, that's once we square the difference, it is again taken relative to expected count. So that's what chi-square test is all about. So quickly, what we do is, so this is a simple example is when we look at, when we go to grocery stores, we'd like to buy milk, and perhaps, we may or may not buy bread along with that, right? So the simple example, or vice versa. We could buy bread and then we decide, whether we need a dairy product with that or not. So essentially, this is so let me quickly show you the raw data set, which is here. So you can see the decisions which are associated with these two categories, whether it's milk and bread, is whether something is picked or not picked. It's a binary variable, right? So milk is picked versus not picked, and when that happens, whether bread is picked or not, right? So these observations are essentially a recording or storing of all the decisions that have taken place over a given period of time. Now, this could be for one customer or more customers. As of now, this is an anonymized data, so we're just basically documenting the decisions that have been taken, right? So a quick way to do that is load this as a CSV, and I'm defining a variable called milk bread. So this function called read.csv, and I'm going to pass file name, which is milkbread.csv, and then I can quickly check whether it has been loaded or not. And a good way to summarize this is look at these entries in a tabularized format, right? So essentially, there's a command called table, and then I will pass this variable which contains the CSV file, and this gives us a nice summary. This is a 2x2 matrix, right? So essentially, on left hand side you have milk, and so this is the first decision. So assumption is that milk is picked first, and then we're deciding whether bread is picked along with it or not. So it's kind of a sequence analysis as well. So when milk is not picked, bread is also not picked for about 75 number of times, and similarly you can make sense of the rest of the observations. So how do you find association, right? So what chi-square metric does is it essentially just tells you whether there is an association that might exist or may not exist, right? So this is a binary outcome. Association either exists or it does not exist. It doesn't go beyond that. So that's the limitation of this test. So we'll quickly look at running this. I already have a command which is stored here for convenience. So chisq.test, that's the command, and then I'm passing the tabular matrix, which is table milk bread, and this is I will come to this parameter later. So once I run this, I get the chi-square metric, which is 17.584, and this is an important one, p-value. This is e raised to -5, and that means it's way smaller than a conventional 5% significance level, right? So Here, so null hypothesis is that the association does not exist, and we have to conclude otherwise. So in this case, the null hypothesis is rejected, and we have to conclude that alternate hypothesis, which is some association that may exist between whether milk is picked or not picked, in order for bread to be picked or not picked. So that's the alternate hypothesis.